This was a question from 2021. It starts off as a easy looking question, and in fairness is very straightforward. A quadratic, and it asks us to solve it. Solve f of x equals 0. So some people are wondering on the day, was it as easy as this? And yes, it was. So you could use your minus b formula, or you could factorize 3x minus 7 times x plus 5 equals 0. If 3x minus 7 is equal to 0, then x would be 7 over 3. And if x plus 5 is equal to 0, you're going to have x equals minus 5. So those are my two roots. You note there is worth 10 marks. And of course, that is quite generous for a question like that, which you would be able to do from junior cert. So it led on then to the second part, hence or otherwise. And the word hence, of course, saying use your answer from the previous part. And we'll see where this comes into play in a moment, but it gives us the clue. It says solve this equation, 3 to the power of 2x plus 1 equals 35 minus 8 times 3 to the power of m. And there is a twist in the tail where it asks us to get our answer in a particular form, and we'll come to that in a moment. But you know, as I always say to students, do the first step first, see where that leads you to. Then that can sometimes bring you, once you've done a certain amount of it, the second part doesn't look so hard. So this is where we're starting. We of course remember that we had this quadratic up here at the top. The coefficients look the same. So what do? We bring everything over to the left hand side, and we can see of course that the coefficients match, so that there's going to be a connection here between them. Now those students who had practiced a lot of questions from the textbooks and old questions, well, they would have been familiar with this type of question here. It's, students who had only practiced, we'll say, the more kind of recent questions would not have seen this one because it hadn't come up in quite a while. But what we do is this. We remember our rules from indices, and our very first rule up here, a to the power of p times a to the power of q is a to the power of p plus q. So what do? Well, we say here, looking at this guy, it's kind of more obvious looking at it the other way around, that 3 to the power of 1 times 3 to the power of 2m is 3 to the power of 2m plus 1. But of course, we want to have it in this lower form here because that's going to help us get to the answer. We also remember that our third law of indices says a to the power of p all to the power of q is a to the power of p times q. One power raised to another power. You multiply the powers together. So in our case here, 3 to the power of 2 times m can be written as 3 to the power of m all to the power of 2. And why are we going to do that? Well, we're going to do it because we know that it's going to get us to the answer. So we're going to have 3 times 3m squared plus 8 times 3 to the power of m minus 35 equals 0. Now we're going to use a technique here that we use a couple of places in the course. We're going to substitute in. Now some people will say you let it equal x, or y, but I'm going to say here let 3 to the power of m equals x in this case. So now all of a sudden we have 3x squared plus 8x minus 35 equals 0, and of course that is exactly what we solved up here. So we can say, well, therefore we can say we know that x equals 7 over 3, or x equals minus 5. So now we have these two answers up here. 3 to the power of m is equal to 7 over 3, or 3 to the power of m is equal to minus 5. We know there's no value of m such that 3 to that value would give you a negative answer, so that guy is out. So now we have 3 to the power of m equals 7 over 3. And now we're looking up here at this part, and it says write m in the form of log p to the base 3 minus q. So again, when you're here, you straight away, you might know straight away what to do, but you just take the next step. We know on page 21 what I call the key rule of logs is this, that if a to the power of x is equal to y, then the log of y to the base a equals x. And what I always get people to focus on is that the base remains the base as you go from indices to logs, or the other way around. And it will be the same here when we introduce logs. So let me do one more step here. I'll do it over here. When we introduce logs, the base remains the base. What was the answer moves to the power, and what was the power moves to the answer. So now we're going to have m on its own. So we have m is equal to log 7 over 3 to the base 3. We think about the second law, the second law of logs here. This is law 1, law 2. That if the division law, log x over y to the base a is log x to the base a minus log y to the base a. And in that case, then what do we do? Well, we say so m is equal to log 7 to the base 3 minus log 3 to the base 3. But this says 3 to what power gives you 3? And of course, the answer to that is 1. So we get m is equal to log 7 to the base 3 minus 1, and that was there for another 10 marks. So you can certainly see the 10 marks earned up here at the start was much easier than the 10 marks earned afterwards, but with enough practice you will get that second part as well.